In this example, we're asked to solve the equation 7 to the 5x plus 4 equals 5 to the x minus 2. In a previous video, I encouraged you guys to consider whether you can express both sides of the equation as a power of the same base. And in that problem, we had a 5 and then we had an expression involving 25. So that was doable in that example. 7 is not a power of 5 and 5 is not a power of 7. We're not going to be able to express both sides as a power of the same base just off the top of our heads in this example. So plan B is to use logarithms to solve these equations. And the reason is, all right, so the goal, like when we're solving any algebraic equation, the goal is to isolate x, right? When x is floating up there in the exponent, you can't really isolate it. Think of it, you can't really get at it when it's up in the exponent in order to isolate it. There's no way to just knock the base out of here. So notice if we take a logarithm of both sides, and you get to take any kind of logarithm you want. We could use log base 7, we could use log base 5. I believe in your homework they ask you to use either common log or natural log, so the log ones that are on your calculator. I'll use natural log. So I'm going to take natural log of both sides. And that's an arbitrary choice. You could just as easily use common log. So suppose we take natural log of this side equals natural log of this side. So the advantage of doing that is at this point then we can take advantage of this property of logarithms that says if you have log base b of m to the p, that's equal to p times log base b of m. So in this case, if we have ln of 7 to the 5x plus 4, that's equal to 5x plus 4 times natural log of 7. And natural log of 7 is just a number. You can punch that into your calculator. It's some decimal number. So it's not a pretty, nice, neat integer, but it is just a number times this 5x plus 4. And the same deal over here. So this exponent can come down, and this becomes x minus 2 times natural log of 5, which again is just a number. You shouldn't punch this into your calculator, though, and then round it off. So don't replace this with a decimal number, because that's going to cause round-off error, which tends to propagate. So if you use that rounded value to do some other calculation in this problem, then your round-off error can become more significant. So it's best to wait. Don't you do a decimal approximation for anything until you've completely solved for x. And it's kind of easier to write if you leave it as natural log of 7 anyway. Okay, so the goal is to get x by itself. In order to isolate x, first thing we're going to need to do is bust these x's out of these parentheses. So I'm going to multiply this out. Natural log of 7 times both parts here. Natural log of 5 times both parts here. So we end up with 5x times natural log of 7 plus 4 times natural log, I got a little sloppy, of 7 equals x times natural log of 5 minus 2 times natural log of 5. We're trying to solve for x. So when you're trying to solve for a variable that appears in your equation more than once, the best strategy to take is to collect your x terms on one side of the equation. Anything that does not involve x, collect it to the other side of the equation. It doesn't matter which side. I'm going to subtract x ln 5 to move the x expressions over to the left side of this equation. And I'll subtract 4 times natural log of 7 so that the parts of this that do not involve x are over on the right side. So that's going to result in 5x natural log of 7 minus x natural log of 5. This is gone, 4 ln 7 minus 4 ln 7. This is gone, x ln 5 minus x ln 5. Minus 2 natural log of 5 minus 4 natural log of 7. So after you collect your x terms on one side, you'll be able to factor out x. So this is x times 5 ln 7 minus ln 5 equals all this over here. And so there's just one step left. In order to isolate x, all we have to do is divide by this other factor, 5 ln 7 minus ln 5 on both sides. So divide by 5 ln 7 minus ln of 5. This is what we call an exact solution to this equation. And so in some of your problems in your homework, you're going to have to type all this in. So be real careful when you do that to not make any typos. When you input this into your calculator, if in your homework you're asked for a decimal approximation, this is when you would pick up a calculator, and not until this point. So a couple of recommendations for if you do need a decimal approximation in your homework. You're going to need parentheses. So you're going to need to do parentheses around that numerator. And in many calculators, when you press the natural log button, many calculators will automatically open a parenthesis. So that's something else to watch out for when you're doing the calculator part of this problem. So when you hit natural log, if it automatically opens a parenthesis, make sure you close it at the end of that logarithm. So -2 times natural log of 5 minus 4 times natural log. So this is where it might do the same thing. It opens a parenthesis, so you'll have to remember to close it. This one closes the natural log parentheses. We would need another parenthesis to close out the numerator. And then divided by your expression in the denominator. So 5 times natural log of 7 minus natural log of 5. So this is what you would type into a calculator in order to get the decimal approximation, which I can enter real quick. If you want to at this point check, if you've been punching this into the calculator and you want to check that you get the right answer. Let's see, so -2 times natural log of 5 minus 4 times natural log of 7, close the numerator, divided by, open a parentheses for the denominator. Okay, and what you should get is approximately -1.35. Wondering where I should round this. Let's go 3 decimal places, so 355.